Hello students, in this video we are going to learn about how to solve more complex problems of goal programming in Solver. Okay, so this is the problem we are going to solve now. As we know that this is a Suncoast office supplies problem, and it has three priority levels. First priority level has two goals. Second priority level has one goal, and third priority level again has two goals. And we will first start declaring our variables. Let E be the number of established customers to be contacted. Let N be the number of new customers contacted. And D1 plus and D1 minus is for goal 1, right? D1, D2 plus and D2 minus is for goal 2. Similarly, D3 plus and D3 minus will be for goal 4. Goal 3, D4 plus D4 minus will be for goal 4, and D5 plus and D5 minus will be the deviation variables for goal 5. So we can write our model or the goal programming model in the combined form like this, that minimize this P1 D1 plus P1 D2 minus plus P2 D3 minus plus P3 D4 minus plus P3 2 D5 minus. Why they have taken 2? Because in there it is mentioned that the fifth, in the priority 3, the fifth goal is twice as important as the fourth goal, right? So this fifth goal here, that is call at least 200 established customers, and the fifth goal is call at least 120 new customers. So this is twice important than this. That is why in this equation we have taken 2 times D5 plus. So here we are going to solve this P1 problem on the first sheet, priority 1 sheet, P2 problem on priority 2 sheet, and P3 problem on priority 3 sheet. So we are going to solve 3 times the solver. These equations are to be captured first based on the information given. And now let me take you to the first sheet where I have already done the setup. So these are my variables. These are the 2 variables and these are the deviation variables. And as we know that we always use the cells below as the variable cells. So we have done the coloring so that we can distinguish themselves from each other. So my first priority is D1 plus and D2 minus to be minimized. So I have written objective function here, minimize D1 plus and D2 minus. So this one, if you see here, D1 plus and D2 minus is there, right? Similarly, for all these equations we have captured here, you can see here 2 times E plus 3 times N minus D1 plus and plus D1 minus, right? So, and equal to 680. So once we set up this, we are ready to solve the first priority 1 problem. So let me solve it here, data, solver, and so my objective is this: minimize by changing variable cells from here to here, all these variable cells, then add. So here, because every equation is having equal to sign, I can use equal to in between and add them in one go. All, sorry, not on the left side, it should be on the left side. Here left side, all the left side, and here on the right side, all the right side, and say OK. Then we are going to use simplex and make unconstrained variables non-negative because we want to accommodate this last requirement, that all my variables are greater than or equal to 0. And now we solve it, right? And when we solve it, actually we can see that D1 plus, right, as well as D1, D2 minus, both are 0. So this is our solution. So you can just capture an answer and say okay, right, we have done this. But what is our uh, findings from this particular first, that D1 plus and D2 minus can be achieved as 0. So when we are doing our next, we are going to use those two equations. So what I will do, I just simply copy paste this, Control C, in my priority 2 sheet. Okay, what are the changes I will do? I will be doing the changes. My objective function is minimize D3 minus, priority 2, D3 minus. So I will change this to D3 minus. Okay, and my D3 minus equal to is here, D3 minus. Okay, then all this remains the same, but I am going to add here D1 plus, so equal to D1 plus, and we have already achieved it as 0, right? So here it is 0. I'll just copy this down, and the second one is, right, my second one is also D2 minus, which is equal to D2 minus. Okay, so I am going to force these two equations because we have already achieved it. So we call it maintaining the achievement. The fifth, these equations are maintaining the achievement. So now we are ready to set. I will just make this all 0, right? And now we have set up this second priority. Use solver. Okay, and in solver again, my objective function is this: minimize, solving all this to be used variables, add. Again, I can do everything in one go. Why I am doing it in one go? Please understand that because all are having equal to signs. If any equation has other signs, I will have to do them separately, right? Then this one here, and if suppose in between there is a less than equal to sign, then I will do the first two together and last 4 together, and this one separately. I can't pick this 2 and last 4 in one go. Okay, so that you have to remember. Then you say okay. Now this is simplex, and you solve. And if you see the answer here, so now my D3 minus also I am able to achieve as 0. So that I am going to take it to my next sheet. So I will just simply copy this, the whole thing, Control C, and take it to the third sheet, where I am going to again do the setup. So this is my P3 problem. So my objective function is minimize D4 minus and 2 times D5 minus, right? So this how I am going to write my equation, equal to D4 minus plus into bracket 2 times D5 minus, right? Also I will make this 0 first, and here I am going to write one more equation, D3 minus is also equal to 0, equal to, which we have achieved in our second stage, right, equal to zero. So I am now ready. I have set up for the third and final priority and goal setup. I have done. I am going to solve this. So my objective function is here. It is minimize type. Variable cells are this all. and add, I will use all this on the left side. I will put it equal to, on the right side I am going to put all this and say OK. Then this one is simplex LP and solve. And now what I got is my final answer. So if you see here, D4 minus can be achieved as 0, but D5 minus will be 60. So what are our final findings? So our final answer is here. My variable E will be, that is 250. So existing customers to be visited is 250. New customers you should target to visit at 60. Okay. Then D1 plus will be D1 plus, D1 minus, D2 plus, D2 minus, D3 plus, D3 minus, D4 plus, D4 minus, D5 plus, D5 minus. Now, okay, and the values are D1 plus is 0, D1 minus 0, D2 plus 80, D2 plus 80, okay, D2 minus is 0, D3 plus is 0, D3 minus is 0, D4 plus is 50, okay, D4 minus is 0, D5 plus is 0, and D5 minus is 60. So what is the findings here? If you look at, if you just take this, this is my answer final, right? I am just taking it to the sheet 1 for the explanation purpose, right? So for the explanation purpose, if I put it here, right? So when I should first, E is number of established customers to be contacted 250, number of new customers to be contacted 60, the amount by which the number of hours used by this Salesforce greater than, so it will be 680 here. The amount of hours used by Salesforce will be 680 only, because it is neither increasing neither decreasing. Whereas the amount by which the number of hours used by the Salesforce is greater than the target of 600. So obviously, because it is 680, it will be greater than 600 by 80, and it will not be less than 600. Then D3 minus is the amount by which the sales revenue is greater than 70,000. So D3 plus, we are going to exactly achieve 70,000, because D3 plus is 0, D3 minus is 0. Then amount by which the number of established customers is greater than 200. So D4 is about established customers. So we are going to go 50 more. So 200 instead of 200, we are going to achieve 250, 50 more. But our new customers was 120 to be contacted, but we are going to fall short by 60. So our fifth priority or fifth goal will not be achieved completely. We are going to run short by 60 new customers. So that is my findings, but this is the optimal solution my goal programming model has given me, where most of my 4 goals are completely achieved, but the 5th goal I am going to run short by 60. So this is how we solve the complex solver problems, where we have to do it 3 times and get our answers. Thank you.